When you think about legendary bridges, what pops into your mind? Probably the Golden Gate in the US, the Millau Viaduct in France, or the Sydney Harbour Bridge in Australia, icons the whole world has looked up to for decades. But while the West is still retelling old glory stories, in a remote mountain province called Guizhou, China has quietly raised a completely new contender. A suspension bridge stretched across a canyon 625 meters, about 2,051 feet above the river. It's so high you'd have to climb to the top of China's tallest skyscraper just to reach it. What used to be a 2-hour grind on narrow mountain roads has been crushed down to just 1 or 2 minutes of flying over open air. Behind that almost impossible shortcut is a machine made of infrastructure, money, engineering, and political ambition. In this video, we're going deep into the Huajiang Grand Canyon Bridge, the highest bridge on Earth, and we'll ask one big question. Is this just another transport project or a new power statement in China's infrastructure game with the rest of the world? All through the 20th century, whenever people talked about infrastructure wonders, they looked west. The US interstate highway system, giant steel bridges, massive dams, ports that helped global trade explode. That was the golden age, when rich countries poured money and steel into projects that pushed engineering to its limits. But in the 21st century, the story started to change. Old infrastructure is aging. New projects face protests, costs explode. Public debt and endless political fights slow everything down. In many places, governments are barely patching up what already exists, instead of dreaming about bold new leaps. Meanwhile, on the other side of the planet, China picked a different path. It decided not just to catch up, but to leap ahead by building an entirely new layer of infrastructure from scratch. High-speed rail, expressways through mountains, suspension bridges over deep canyons, deep water ports. And Guizhou, one of the poorest, roughest provinces in the country, became the laboratory for that strategy. Locals here have a saying, there isn't 3 feet of flat land. More than 90% of the province is hills and mountains. Roads twist and climb, cutting communities off. From being almost an island in the middle of the mainland, Guizhou is now being pulled straight into China's national transport network with tens of thousands of bridges. And Huajiang is the boldest piece in that puzzle. Right above a massive crack in the landscape that locals call the fracture of the earth, the Huajiang Grand Canyon, a steel and cable giant has appeared, the Huajiang Grand Canyon Bridge. This bridge has a total length of about 2.9 kilometers, around 1.8 miles, a main span of 1,420 meters, about 4,659 feet, across the canyon, a deck about 625 meters, around 2,051 feet, above the Beipan River, making it the highest bridge in the world, around 22,000 tons of steel in its structure, nearly 3 times the steel used in the Eiffel Tower. Before Huajiang, crossing from one side of the canyon to the other could take up to 2 hours. Drivers had to crawl over mountain passes, hugging sharp curves on dangerous roads. Once the bridge and the S57 expressway opened, that same journey shrank to just 1 to 2 minutes. A stretch of road that used to choke the region with high transport costs has turned into a gateway linking Luqi, Anlong, and the wider expressway network of southwest China. On paper, a suspension bridge sounds simple. Build the towers, string the cables, hang the deck. But doing that over a canyon more than 600 meters deep in complex geology turns every step into a literal high-wire act. First, engineers had to choose the type of bridge, cable-stayed or suspension. With a main span of more than 1.4 kilometers and hard rock mountains on both sides, a steel deck suspension bridge made more sense. The main cables could be anchored deep into the mountain slopes, using the rock itself to create massive stability. Before a single ton of steel went on site, they built a full digital model to pre-assemble all 93 deck segments on a computer, a kind of virtual trial run. Every segment, every deck panel was assigned a precise position, order, and rotation so that on site, the whole thing could be put together like a giant Lego set hanging in the sky. But how do you lift steel blocks weighing hundreds of tons up more than 600 meters? Even one of the world's largest cranes, Big Carl, at about 250 meters tall, would be barely half the height needed. Instead of trying to build a mega crane, China used something more elegant, an aerial cable crane system stretched across the canyon. Imagine a runway in the sky. Steel deck segments are brought to each end of the bridge, hoisted up to the cable system, then slowly slide out over the canyon like a suspended train car. From the center, crews assemble the deck in both directions to keep the structure balanced and avoid dumping too much load on a single tower. At that height, a positioning error of just a few centimeters can become a disaster. So the exact location of each segment is adjusted using China's Beidou satellite navigation system, their version of GPS, to match the 3D design down to the millimeter. The steep terrain means the foundations on both sides of the canyon are not symmetrical. One side has a higher rock face, the other is lower with different rock layers. The result? The North Tower is about 262 meters tall, roughly 860 feet, while the South Tower is around 205 meters, about 673 feet. The anchor blocks behind each tower are also arranged asymmetrically, dug into different rock strata at different elevations to spread out the forces. In the real world, the Huajiang Bridge also has to live with earthquakes and wind. Guizhou isn't China's most violent seismic zone, but ground movements are still enough to make a kilometer-long suspension system sway like a giant pendulum. To handle that, engineers installed dampers, basically huge shock absorbers, at both ends of the structure. These devices absorb movement during quakes and let the bridge expand and contract as temperatures change. Wind is an even more dangerous enemy. The canyon creates a Venturi effect. When wind is squeezed through a narrow neck, its speed shoots up and pressure drops, creating sudden gusts that some have compared to high-speed trains. Beyond computer simulations and wind tunnel tests on scale models, Huajiang is monitored using Doppler LiDAR. The system fires laser beams into the air and measures frequency changes in the reflected light from tiny water droplets, building a 3D map of how wind is moving through the canyon. In other words, they don't just measure the wind, they see it. When the bridge entered service, the monitoring didn't stop. Inside, the cable bundles are optical fibers as thin as hair. Whenever a cable stretches under load, the fiber stretches too. By sending light through those fibers and reading the reflected signals, engineers can tell how tight the cables are and spot problems before they turn into failures. Economically, the Huajiang Bridge and the S57 Expressway cut travel time through the canyon from about 2 hours down to 1 or 2 minutes. Multiply that by thousands of vehicles every day, from trucks to buses, and the time, fuel, and logistics costs saved add up to something huge. Districts and towns that used to sit in a low zone are now right on a major transport spine. Logistics companies open depots, rest stops, and gas stations. Hotels and homestays welcome travelers. Factories, cold storage facilities, and processing centers for agricultural products appear where hills once just sat there doing nothing. Socially, once the road is no longer the main barrier, young people in Guizhou don't have to move to megacities at any cost. Job opportunities start to move closer to home. Construction workers, toll station staff, tourism services, and bridge and road maintenance engineers. Geopolitically, Huajiang is just one piece in a much bigger picture: China's war on poverty and the Belt and Road Initiative. By pouring resources into poor provinces, China is both fixing internal gaps and creating a new economic corridor in the southwest, directly competing with other transport routes and gateways in the region. A 625-meter high bridge isn't only carrying vehicles over a canyon. It's carrying goods, capital, and political influence closer to the rest of the world. When the first images of Huajiang spread online, a thin line of steel stretched across nearly 700 meters of empty air above the river, social media in Europe and the US almost couldn't believe it. One person joked, "I always thought the Golden Gate was the peak. Turns out it's just the ground floor." Another half joked, half complained, "We're now only good at arguing about projects. They're out there cutting mountains and hanging bridges." At a glance, the Huajiang Bridge is just another steel and cable suspension bridge, one more highest in the world record on China's already long list. But if you look closer, it's a stress test for a lot of things. The vision of leaders who dare to slice a mountain in half and hang a bridge over a deep canyon to open up the future. The confidence of investors willing to pour hundreds of millions of dollars into an area once seen as a dead zone, and how serious a country really is about long-term infrastructure strategy instead of just patching things up piece by piece. From being labeled impossible to build and hard to develop, Guizhou has been pulled onto the map as living proof of a simple principle. There's no terrain that's too hard, only vision that isn't big enough and willpower that doesn't last long enough. Huajiang is a bridge made of steel, but it's also a concrete statement about where China wants to stand in the infrastructure order of the 21st century. From the 625-meter high Huajiang suspension bridge to the S57 expressway cutting straight through rock and the tens of thousands of other bridges rising all over Guizhou, a new picture is forming. China isn't just chasing old infrastructure standards. It's writing its own rule book for speed, scale, and ambition. What about you? Which part of the story surprised you most? The dizzying height, the way they assembled hundreds of tons of steel in midair, or the strategy of turning a single bridge into a tourism engine, an extreme sports stage, and a logistics machine all at once? Tell us what you think in the comments. If you found this video helpful, don't forget to hit like, subscribe to the channel, and share it with anyone.